So I think there's a good chance when I talked about supernova events where a massive star blows up, ends its life because its core it has a core of iron, and it contracts and tries to heat up that iron to fuse, but it can't fuse that iron, so it blows up. I think when I talked about that supernova event, I said actually there's two types of supernova. So the one we talked about in the previous chapter, in chapter 12, was actually this type. We call it type 2 supernova. And like I said a minute ago, it's just a star that's more massive in general than 8 solar masses. As it's a main sequence star, it ultimately gets to the point where it does fuse silicon into iron in its core, but it's not going to go ahead and fuse iron. So it will end up, as we said, either a neutron star or a black hole, and we're going to talk more about those in chapter 13. So that's the type of star that blows up, type 2. Well, there's this other type of supernova called a type 1A supernova event, type 1A. And I'm going to want you to differentiate between these two types of supernova. I wish they'd called them something different, but they didn't. The type 1A supernova is also a star blowing up, but it's a star blowing up, if you're listening to these lectures in order, when I talked about novas, okay, it's the same situation. So when I talked about a nova, I said that's a case where you have a binary star system, and you have one of the stars is retired, white dwarf, and the other star is expanding. It must be in some sort of giant stage, and it's dumping on its companion, white dwarf. Well, we get novas out of those. But we can also get something called a supernova, another type of supernova, 1A. And what happens is that retired star, that white dwarf, comes out of retirement. This is to say that matter that we talked about kind of getting in the accretion disk and heating up and kind of blowing off to make a nova event. Well, that matter, think of that matter as making it to the white dwarf itself. Some of it anyway. And so basically, as that matter piles onto that retired star, it heats up that orb, which is basically a chunk of carbon. It heats it up, and eventually it will go ahead and you'll have carbon fusing. But the problem here is when the star comes out of retirement, so to speak, where that white dwarf begins fusing carbon, it doesn't have the mass it used to on the outside to kind of settle into anything. So it's one big explosive event. It can't really contain its fusion in any sort of core. It's kind of an exposed core of a star as it is. So the star blows up. Okay, so do you see where nova and supernova type 1A have the same setup? But supernova type 1A, the whole star does blow up. Okay, so one of the ways then to kind of well, I should say, put it this way, scientists or astrophysicists need to be able to, when they see these explosive events, and actually we're going to see in a later chapter, we can see supernova occur in distant galaxies. When we see these events happen, we need to differentiate, well, was it a massive star ending its life, or was it white dwarf that was getting dumped on by its companion and it began fusing carbon and blew up? And these are light curves, and notice what they're showing you is the decay of how bright it is over time. So along the x-axis you have time in days, and along the y-axis you have luminosity. Now to me, so I can't really tell a lot of difference. It looks to me like the red line, which represents the type 1A supernova event, is initially brighter and just has a little different decay. It's more linear decay. And then the type 2 supernova event, where a massive star blows up, it kind of is not quite as bright, and it kind of has a little bit of a different decay process. So that's supernova type 2 and type 1A. So now how do you distinguish between the supernova 1A and the nova? Well, one big difference is that those nova, I should say the supernova type 1A, are much, much brighter than the nova. Remember, nova occur actually in the accretion disk, where fresh hydrogen coming from a companion star heats up to the point of fusing into helium, and it's just a kind of flash sort of thing. So supernova 1A are a lot brighter than nova. But nova can reoccur, and I think I mentioned that before. A supernova type 1A, then, where a white dwarf blows up, you will not, after this event, get the same thing you get in a supernova type 2. You will not have a neutron star or a black hole. Okay, it basically blows up, all gone. Okay, so somewhere in your brain or partition, I want you to know that when we talk about the different types of supernova, type 2 is when a massive star ends its life and leaves behind a neutron star or black hole. A type 1A is where a white dwarf blows up because it got dumped on by a companion. And their light curves can differ. Again, I just think that's a subtle thing. One of the differences too is that the 1A, because of the nature of it, when a white dwarf blows up, we don't see those hydrogen spectral lines like we see in the type 2.